Okay, so on to tab 2 of the angles of elevation and depression exercise on my iMaths. So the first question there, I'll just flip to my whiteboard and describe the question. So it says, a man 2 meters high, and then you've got 2 meters in there on the diagram. So the man is there. A man 2 meters high. That's supposed to be a man. Observes the angle of elevation to the top of a building to be 57 degrees, and then they give you 57 degrees in there, and the angle of depression to the bottom of the building to be 24 degrees, and they give you 24 degrees there. So obviously the man's eyes aren't at the bottom of the building because he has a certain height. So there's his eyes. So from his height up to his eyes, if he looks down to the bottom of the building, 24 degrees. But if he looks up to the top of the building, 57 degrees. And then you are asked, how tall is the building? So the only information that you've got is 2 angles and the man's height. So this is going to probably take a couple of steps to get all of the information we need, but I'm going to work with this right angled triangle here. I mean, basically, if you take everything away from this problem, all of the kind of context that's built into the question, it's a bunch of right angled triangles, and you've got to figure out some missing sides. So I'm going to look at this triangle that's got the 24 degrees in there, and if that's 2 meters over there for the height of the man, then it's 2 meters on the other side as well. And then I've got another right angle triangle here with the 57 in, and all we know at this stage about the 57 degree triangle is the 57 degrees. We don't know any of the sides, but we notice that it shares a side with the 24 degree triangle. So if we can use the 24 degree triangle to figure out how far the man is from the building, then we can use that information in the bigger triangle. Okay, so I'm going to rub out everything at this stage that is not a triangle. Okay, so in the bottom triangle, you've got 24 degrees. You've got the opposite side to the 24 degrees, which we know to be 2 meters, because it's the height of the man. We'd like to figure out how far the man is from the building, horizontally from his eyes, because that distance is also in the other triangle, and it will help us with the other triangle. So in relation to the 24 degrees, that's the adjacent side. And in fact, it also happens to be the adjacent side of the other triangle in relation to the 57 degrees. So that's going to make things a little bit less confusing ultimately. So we've got opposite and adjacent. That's tan. Generally speaking, tan equals opposite over adjacent, and in this particular case the opposite is 2, so I can just put 2 there, and we're talking about the tan of 24. Tan of 24 equals 2 over the adjacent side. If I multiply both sides by the adjacent, then the fraction disappears, but I get times the adjacent over on the left. So the adjacent times tan 24 equals 2, and then I want to get the adjacent bit on its own. So if I divide everything by tan 24, I get the adjacent bit on its own, and 2 divided by tan 24 on the right. So anyway, 2 divided by tan 24 close brackets equals 4 I'm going to call that 4.492. It's 4.492, but I'm just going to keep a slightly over accurate value for now and do all my rounding at the end, because if I do too much rounding along the way, I'm concerned that all those little rounding errors will accumulate and make you a long way off at the end. Okay, so I've now got the big triangle where I figured out the adjacent side, and it is also adjacent in the big triangle to the 57, and then the height of the big triangle is the opposite side to the 57. I don't like having two things called opposite, so let's call them op1 and op2, just so that we've got some kind of consistency with the notation. Okay, so the opposite side and the adjacent side and the 57 degrees are what we've got in the big triangle. So that's going to be tan again. So tan equals opposite over adjacent. The angle in this case is 57, so we're talking about tan of 57 degrees. The opposite is, well, this thing that I've decided to call opposite 2, from there to there. And the adjacent is the slightly over accurate 4.492 that I worked out. So if I multiply both sides by the 4.492, I get 4.492 times tan 57. Let's just bring that a little bit more into shot. Is equal to opposite side 2. And in fact, I've still got in my calculator the very accurate version of that 4.492. So all I've got to do is multiply it by tan 57, and that gives me 6.91. 6.91. So that's telling me that from the top of the building to his eye level is 6.91, and then plus the extra 2 that was his height gives me 8.91. So I'm going to fill in 8.91 on iMaths. So that's to one decimal place, 8.9. Now I'm making a little bit of a flawed assumption in all of that, that his eyes are somehow at the top of his head, which isn't necessarily valid, but there you go. Okay, so the next question says, from a point at the water's edge, which is down there in the corner, a bridge arch is 51 meters away. So they've got a triangle there, and 51 meters to the bridge arch, and it has an angle of elevation of 3 degrees. So they've got an angle in there that's 3 degrees. And then, although it doesn't look like a right angled triangle because there's a whole load of perspective going on, this is obviously supposed to be a right angled triangle because it's from directly under the bridge to straight up. And then it says, and the top of a yacht mast 14 meters away, and they've told you 14 meters along there for the 14 meters, has an angle of elevation of 13 degrees. And again, they've drawn 13 degrees in there. So although the diagram's a little bit confusing, it's basically two right-angled triangles, two different right-angled triangles, I should say, and you've got information about both of them. So I'm going to start with this right-angled triangle here. I'm just going to draw another one over here so it kind of looks more like a right-angled triangle. So this is the 3 degrees. Obviously that's not 3 degrees, that's a lot more as I've drawn it, but this diagram is just illustrating the point. So the 51 along the ground, and in relation to the 3 degrees, that's the adjacent side. And we'd like to know the height of that triangle because it's the amount of space under the bridge. So that's opposite to the 3. So opposite and adjacent, that's tan. So tan of 3 degrees equals opposite over adjacent equals opposite over 51. So the opposite side itself must be 51 times tan of 3. I just bring that back into shot. Yeah, so the tan, so tan of 3 equals opposite over adjacent. Tan of 3 equals opposite over 51 is the adjacent. Multiply both sides by 51. 51 tan 3 gives you the opposite side. So I can do that on my calculator. 51 times tan of 3, close bracket, is 2.67. So the amount of clearance under the bridge is 2.67, whatever the units are, meters I suppose. Meanwhile, the height of the boat. So the height of the boat is another triangle, so I'll just draw another quick right angle triangle to get everything in the right place. So this time 13 degrees for the angle of elevation to the boat, 14 meters along the ground, and that's the adjacent side again. And again we'd like to find the opposite side because that's the height of the boat. So exactly the same thing as before. I'm just trying to find somewhere where I've got enough space to do that. Let's move those. So tan equals opposite over adjacent. In this particular case, tan 13 equals the opposite side over 14. That says opposite, in case you were wondering. So 14 times tan 13 gives you the opposite side. Let's just roll that off. Okay, so 14 times the tan of 13 degrees gives you the opposite side. Let's work that out on the calculator. So clear that, and 14 times tan of 13, close brackets, equals 3.23. 3.23 is the opposite side, so 3.23 is the height of the boat, but it's only got 2.67 clearance under the bridge, so it's not going to make it. So the bridge was to one decimal place, well I said 2.67, so to one decimal place 2.7. The yacht was 3.23, so to one decimal place that was 3.2, and therefore it's No, not going to make it. So let's mark that. 6 out of 6.